right, so I'm going to spend some time going through some of the review questions. I won't hit all of them, but I'll go through some of them. So I'm going to start from the first page of the review packet and talk about the sketches of the curves. So there's the linear, the quadratic, and the inverse. And so the linear graph, it's that shape, and y equals mx. The quadratic graph, parabolic, y equals x squared, and the inverse graph, y equals 1 over x. So you should know those shapes, know which one's which, and the significance of those relationships. Moving on to number 2, so there's going to be some sig fig type questions on the midterm. So there are 4 rules for determining the amount of significant figures a number has. You can have that any number 1 through 9 is significant. So for example, if you have 289, that's 3 sig figs. So any non-digit number, any non-zero number is significant. Zeros are where it's tricky. So if it's a trailing 0 after a decimal point, it's significant. So if you have 3.0, that's 2 sig figs. If you have 3.10, that is 3 sig figs, because there's a trailing 0 here, which is also significant. Rule number 3 is any zeros between 2 other sig figs, including the ones that are at the end, are also significant. So for example, if you have 450.0, or sorry, 45.00, obviously that's four digits from rule number 2. But if we have 450.00, that's 5. This 0 is significant. Whereas if we just have 450, this is just 2 sig figs, not significant. That 0 is not significant there. And then rule number 4 is any zero that is placed any zeros that space the decimal point are not significant. So that 0 there is not significant in 450. But if you say something like 450 point, that 0 is significant. So the decimal point there matters. All right. So if we look at some examples here, so 0.419, this has 3 sig figs. That leading 0 is not significant there. 7,007, these 2 zeros are significant. And so this has 4 significant figures. And these 2 are significant because they're between 2 other significant numbers. 1001.0101 is all of these are significant because you have a ending 1 and a beginning 1. So everything in between that is significant. So there's 8 sig figs there. Here, 8,800, that's just 2 sig figs. These 2 zeros are not significant because there's no decimal place underneath that. And then 0.050 has 2 sig figs. These 2 are significant. The leading 0 is not. That's the one that rule number 4, that's spacing the decimal place. And then here, 25.00, all 4 are significant. Okay, so it's just a little bit of quick rules on sig figs. We're going to do some scientific notation now. So it says take the following numbers and place them into, or take them out of scientific notation. So here you have 3.85 times 10 to the 5th. Whenever you see like a positive exponent, it means the number is going to get larger. When you have a negative exponent here, -4, it means it should be a smaller number, a decimal number. So large positive, large number. So we have 385,000. If you look at the decimal place, it moved from 5 spaces. Right, so that's all this is about, just moving the decimal place. Whenever it's a negative, you move it the opposite way. So Here we're going to move it 4 spaces, but to the left. So it was here, and now it's moved to there. So negative moves it to the left. It makes it have a smaller number. So here 10 to the 8th. So that's going to be 299, and then followed by 6 zeros, moving the decimal place 8 places total. All right. So you got a couple more examples. Here, taking the numbers and putting them into significant or scientific notation. So there's 3 sig figs here. These 3 numbers are significant. So our scientific notation will also have 3 sig figs, 4.12. And then we just count the zeros. There's 5 zeros there, and then the 1 and the 2. So it has to move 7 places. This is going to be a positive number here because the number is large. 4.12 million is a large number, and so we have a positive exponent. Where here, this is a small number, so we know we're going to have a negative exponent. Again, 3 sig figs. So we write that 2.36 as our 3 significant figures. But this is going to be moving the decimal place to the right here, 4 spots. So this will be times 10 to the minus 4th. And then lastly, this one's also small, and so we're going to have 1.23, 3 sig figs, and then this one's moving the decimal place 3 times, so 10 to the minus 3. That's how the scientific notation works. All right, on the back of this worksheet, we had a whole bunch of dimensional analysis questions, so I'm going to go through those. On the midterm, you're going to have some stuff on the dimensional analysis, unit conversions, stuff like that. So, all right, so here we go. How many seconds are in 3.5 years? So when you're doing this type of problem, always start off with what they give you, 3.5 years right here, and then just go from there to the desired unit. And so we're just multiplying by our conversion factors. So 1 year, we know that's 365 days. Multiplied by days to hours. So days goes on the bottom. And 1 day is 24 hours. So 24 hours is on top. And then there are 3,600 seconds in an hour. Hours goes on the bottom. Cancel that out. And 3,600 seconds, 60 times 60, 60 minutes in an hour, 60 seconds in an hour. That's how I came up with that number, 3,600. Multiply across the top, divide by 1s across the bottom. And if you look what happens with the units here, right, we get the years cancels with the years, the days cancels with the days, and the hours cancels with the hours. And so all we're left with is this unit here. And we get 1.10 times 10 to the 8 seconds. There's our answer there. Okay, how many inches are in 20 meters? So this one's a distance one. So again, starting out, always put the one we're starting out with on top, 20 meters. And now we got to go to inches. So we have the conversion factor that 1 meter is 100 centimeters. We have to go to centimeters first because we know the conversion between centimeters and inches. There is 2.54 centimeters in an inch. All right, and again, we can see the meters cancels, centimeters cancel, and so what we're left with is inches here. And so we can do 20 times 100, divide by 2.54, and get the answer of 787.4 inches. Okay. Now, what happens if they give us 2 units? So kilometers per hour here. They give us 50 kilometers per hour to miles per hour. Now, in this case, our base, when you have 2 units one per another unit, just put the second unit on the bottom like this. So 50 kilometers per 1 hour, and then convert it to sorry, we don't have to worry about hours because we're going to hours here. So the hours on the bottom is going to stay the same. We just got to go kilometers to miles. So we'll put kilometers on the bottom here. And then if you know how many miles are in a kilometer, then you can do that conversion right away. But in this case, we don't have that conversion right away. We do have how many meters are in a mile, given at the top it says 1610 meters in a mile. And so we need to go to meters first. And there are 1,000 meters in a kilometer. And now we can do, there are 1,610 meters in 1 mile. And again, so we can cancel out kilometers with kilometers, meters with meters. And what we're left with is miles here per hour there. So we multiply 50 by 1,000, divide by 1610. And we get our final answer of 31.06 miles per hour. All right. Let's see. So this one's now saying 36 miles per hour. What is the speed in meters per second? So this one we do have to convert both. So I'll show this one as well. And then probably be the last one I do. Well, and I'll do one more at the last one on this page. So 35 miles per hour. Again, starting by putting 1 unit on top, 1 unit on the bottom. We want to go to meters per second. It doesn't matter which way you start here. So we can do the same conversion we did before, except reversed. So I'm going to go miles to meters. 1 mile was 1,610 meters. And then I can do meters to kilometers. Or sorry, I don't need to actually go all the way to... don't need to go all the way to kilometers. I just need the speed in meters per second. So that's good. I'm in meters. Miles cancels. I have meters per hour now. And now I need to convert the hours. So hours now goes on top because it's on the bottom on the left-hand side. It needs to go on top so that it can cancel. And then I want to go to seconds. So again, I can do this in one step. There are 3,600 seconds in 1 hour, which is 60 times 60. And so again, the meters cancel, or oops, meters, the hours cancels with the hours there and there. And what you're left with is meters and seconds. Multiply those out, divide by 3,600, and you get 15.65 meters per second. Okay. So the next few are just pretty similar. Grams to milliliters, pounds to gallon. You can kind of go through that one in the same way. 40 miles per gallon to kilometers per liter, same thing. Same idea there. This last one is the only one that's a little bit different because it's got this meters per second squared that we need to convert to feet per minute squared. And so I'm going to start with the same way that we've done the other ones, 9.8 meters per, and then second squared is going to go on the bottom. That's 1 second squared. Now, this is really seconds times seconds. And so we have to convert seconds twice. Well, let's start with just meters to feet. All right, so I know that there is, I don't know exactly how many feet are in a meter, but I do know how many feet are in a mile based on that let's see. I don't think I gave you that one in the, no. I didn't give you this conversion factor, so this might be one you write down on your reference sheet. But there are 1,610 meters in a mile. And in 1 mile, there are 5,280 feet. And so that's how I can go from meters to feet. See, the meters cancels. Miles counts. I'm left with feet on top, feet per second squared. Now I want to go feet to minute squared. And so here, I want to go seconds squared to minutes squared. Now, there are 60 seconds in 1 minute. So there are 60 squared seconds in 1 minute squared. So you have like this double where we're doing this twice. There's actually 2 factors of 60 there. And so when I multiply this through, I do 9.8 times 1 times 5,280, and then I multiply by 60 twice. And then I divide by the 1,610, and you're left with 115,700.9 feet per minute squared. And again, just looking at the units here, you can see that the second squared here cancels out with this, the second squared here. And so what we're left with is the feet and the minute squared, which is what we have here. Okay, so that's dimensional analysis, and that is review sheet number 1.